Alright, today, good day all. Hopefully everyone is stay safe and stay healthy. So today I'm going to discuss on chapter number 7 actually in our course here of modeling in economics, and this chapter is about focusing on error correction modeling, or if we put a V in front, it's called vector error correction modeling, or VECM, or the ECM. So ECM will be the single equation and VECM will be the multiple or inside the vector of regression. So last chapter we have discussed about VAR, and before that we also discussed about the angle and Granger co-integration, and last chapter about the VAR, vector autoregression, which is actually made popular by Christopher Sims. And then after that we extend our discussion on Johansson and Jusilus co-integration test. So now it's an extension. So basically before we start, as a prelude or as a preview of what is happening before this, certainly at first you have to test the unit root of each of the variable, and then after that we will go into the next steps, which is to test the long run relationship between the variables. One of the earliest way of doing the co-integration is using the angle Granger 1987 approach, which is based on single equation, or normally the literature will call it residual base test co-integration test. I repeat, residual base test co-integration test, which is actually in line with the more latest co-integration test by Pasaran et al. 2001, which is also based on residual base test co-integration test, which is among others from the innovation from Engel and Granger, improvement for Engel and Granger. The Johansson and Jusilus co-integration test for long run relationship is a different setting, where they have put the setting of VAR inside there, multivariate setting, and the VAR have one interesting features is that you treat all the variables endogenously, meaning that it doesn't matter how's the sequence of the variable, you will get the same results of the co-integration, which are already shown to you in the chapter number 6. So we move on with error correction model, which is actually to test the short run and the long run of the model itself. And in this chapter also we introduce to you also the Granger causality in the environment of VECM in that sense. So there will be short run and long run in this particular chapter. So before certainly the manual for today is that the introduction with a bit of downline memory. We'll talk a bit on the last econometrics, last chapter of the econometrics, and then we discuss on the VECM, ECM, the condition of ECM and VECM, and the Granger causality, the application of Granger causality. Certainly that is what the interest also for the chapter. And then the empirical application. The empirical application I will show to you on e-views, which I will be conducted in another video, the second video of this chapter, right? So we certainly will start this chapter with the previous subject, econometrics. Remember back your chapter 17 in Gujarati and Porter, or chapter number 12 actually in your econometric course, where I'm going to introduce back to you the two model, which is called Kojak and PA. PA is partial adjustment model, which is actually a mimic. It's quite similar to the ECM error correction model, of which you read through this part, very straightforward. It's a dynamic model, dynamic model, which characterizes the deviation of the current state from its long run relationship with this short run dynamics fact. Means that there's a long run relationship which is already been justified in co-integration test, and then you have a short run deviation towards the long run. From here we will have the answer how long it's going to take for the model or for the system to go back to the equilibrium from the measurement of ECM, or in other words with the idea of adjustment, partial adjustment, or Kojak model, which I'm going to show you, right? error correction model is not the model that correct the error in another model. This is not the model. This is not what error correction model is, right? So this is downline memory of the chronometrics. Yet it started off, correct model started off with something like infinite lag model, where you have lag of independent variable, right? X here, distributed lag model. And then after that, you have something called like this, the decay, or we call it in the literature or in the book, we call it a speed of adjustment, which measures the adjustment, how fast the decline or the decay of this distribution is. The number will go more than 0, less than 1. That's the speed of adjustment. Same thing goes to ECM, which I'll show you later, right? It implies that how fast the coefficient move, how fast the adjustment move from the model from one to the other. And this is what in ECM we'll call this a short run short run disequilibrium to the long run equilibrium, right? Which is a very familiar word in the error correction modeling, measured by the ECT, error correction term. All right, so and then we have another model called partial adjustment model, which is by Nerloff, Mark Nerloff, or the function itself. The function itself here, you have a one new terms which is called partial adjustment here, which measures actually the delta, actually measures the coefficient of adjustment, the changes from one to the other one, right? To where it is postulated the actual change in capital stock, for example, in this case, in any given period of time t, is a fraction of the delta of the desired change in that for that particular period, right? So if it's equal to 1, then is actual is equal to the desired. If it's 0, then nothing changed. So the number or the figure actually goes from 0 to 1, or usually more than 0, less than 1, which is actually shown by here, right? Less than 1, more than 0. So it can be 0.1 up to 0.9999, for example. And this one, the delta will lies between the two extreme, and then it's called it partial adjustment model. So this is the idea behind the error correction model. Why we need to use this kind of modeling structure? Because for the simple answer is that once we have detect long run relationship, which we use co-integration tests, either you use angle Granger, Johansson Justice, or maybe the ARTL, which I didn't show in this class, but I can show certainly maybe in our online meeting. Surely that this variance of co-integration, the main objective is to find the long run relationship. So now actually if we found that there's a long run relationship, then how we should proceed, how we will need to proceed. And the proceed is that we need to know how fast is the adjustment from the short run to the long run. And that's the interesting part about this econometric methodology, or the modeling side of the methodology, is because it can answer back our economics theory of an application in the real time, in the real scenario for the economics phenomenon, right? So basically, this is the general idea or the theoretical understanding behind Granger causality test in VECM. It's still the same Granger causality, 1969 by Cliff Granger, 1969 by Cliff Granger. Certainly is in this VECM is an improvement from the bivariate Granger causality that you have been exposed to in your econometric course last semester. This is an extension, and the application is towards the VAR understanding, VAR, because of the vector here. All right. So this is the implication. This is from the what you could do behind the idea of Granger causality in the VAR sense. An important result of co-integration analysis is Granger representative or representation theorem, which deal with the modeling of short-run dynamics. Now we have to know the short-run dynamics because the causality shows the short-run dynamics, but there's a long-run causality also. But do not get confused with that. First, I'll show you in the part 2 where we do the estimation in EVs, which one is short run, which one is long run, and so on. Right? So this is from the co-integration, again repeated. Although individual time series are non-stationary, they are linear combination that binds them together, or the common trend, and then the equilibrium force them to keep such series move together in the long run. That's why you can find co-integration. So actually, co-integration concept also, if you apply to the real life, is like you looking forward into a more formal relationship, rather than a couple maybe start off with a girlfriend, boyfriend, and then since school days maybe, or they're couples in school days, and then plan to get married maybe 10 years down the road. So that's the long run relationship. So they try to bind together, tends to keep together in the long run until they get married, until they have a family by their own, and so on and so on, until they get old. And so that's to maintain the equilibrium. And that's the idea, again, if application towards the family lifetime. All right, so if this is the important criteria, if co-integration is detected, right, then the Granger causality must be conducted in vector error correction model to avoid problem of misspecification. This one you can always cite Granger 1988, an important article for this. Otherwise, you can do first different standard vector autoregressive model, or in short, you can call it VAR, VARL, L, right? For no, sorry, VARD. L is level. VARD, VAR in first different. Right? VECM is a special case of VAR that impose co-integration in the variable. So if co-integration exists, means that if the variable are not co-integrated, there's no long run. So we just have to find the short run relationship using the VAR in first different. Right? If there is a long run, then we proceed with VECM, which is a special case only for a long run. Here, our focus is on VECM. Certainly, I will show you also what is ECM in the estimation part, the idea behind. Right? See, you see that if co-integration is just co-integration indicate the presence or absence of Granger causality. Means that if co-integration exists, means that there's supposed to be a causality, but we do not know the direction of the causality. That's where we need to test further. Right? You need to test further from the derivation of the long run co-integrating factors. All right, this is from Johansson series. If you test angle Granger, or if you test ARDL, then normally the extension will be ECM, error correction model. If you test Johansson series, found co-integration, then we proceed with VECM, Granger causality. All right, so certainly that been indicated in the last chapter, number 6 especially. VAR is important for forecasting, analyzing the behavior, comparison, and so on and so on, or formulating new theories. It's also it's also certainly can answer the idea of Granger causality in the sense of ECM and VECM, including the error term component. Right? This dynamic relationship will certainly provide a better policy implication, a better kind of movement or interplay between the variables, and the authorities or the government will be able to know what is actually happens. There's numbers of articles actually published on VECM that since 90s. I was very grateful, especially to numbers of authors, especially the one authors that I always look forward to their article, which is Professor Abul Mansour Maseh. Article like 20 years back. Learned a lot from him without going to his class because he was not based in Malaysia then, and now he's in Malaysia. Now he's I think right now he's I'm not sure, in one of the private university. Previously, few years back, he was in INSEF, the Islamic Finance University, and now I think he finished his contract there and changed to another private university. But then again, I learned a lot from him in the 90s, late 90s, when I doing my master's and PhD, to know all the concept of VCM and ECM. The article is really good, very, very, very informative. I will share with all of you in the ellipse. Certainly, the article is very interesting to read. I'll show some of this article here. So this part of it is actually I got it from Maseh article, and actually the authors of Maseh is Maseh and Maseh. One is his son and the father and the son article. So the gradual causality can be exposed either through statistical significance of ECT joint test and or joint test in terms of the error term, or the set of the terms described in number 1, or by F test or word test, taking it separately. This one is actually just a testing. It's more on how the mechanics behind EViews doing the estimation. And then the F test or the word test being used in first difference indicate the short run, while the long run causal relationship is implied through the ECT. So this might be the confusing part. But then again, I'll get back to you again on this part. When you do the estimation, we'll go back to you on this part. This will be the part number 2. For now, you accept as what is it. Right? The ECT, which is the error correction term, can be consistently obtained corresponding lagged residual of the single equation co-integration regression. Relevant ECT must be included in the VAR to avoid misspecification. Yet, surely that the existence of co-integrated relationship in the long run indicates that residual from the co-integration equation can be used as a ECT. Like for example, as follows of this one I adopted from one of my article 2010, 10 years ago. The article published 10 years ago that talks about twin deficit, and this is the simple equation of the 2 variable. Although it's just a 2 variable, but we use also Johansen-Jusillis to test it, and then we proceed with granular causality. This is how you can write the granular causality. This is the ECT term just now, the ECT term which measures the long run relationship. If you realize that there's the triangle here, the triangle here measures the short run, which is actually first different. As we see here, first different. But this is not. So this is the long run, and this is the short run, which is actually correspond to what the previous slide is, right? This previous slide, right? The explanatory variable in first different is considered the short run causal relationship, and this is the long run causal relationship. All right, it might be confusing again, but it's okay. If you need more explanation, surely that we can do this again. We surely that when we meet online, certainly I will go back to this again and again, or you can watch this video all over again and again. So this part is short run if you have the causality, and this part is long run. For example, if this relationship or this hypothesis is being rejected, means that budget deficit will cause current account deficit. Certainly we not bothering about testing yourself to yourself. And here, current account deficit to budget deficit. And if this is significant, means that there's a long run relationship, long run causality from current account deficit to budget deficit, because the dependent variable is budget deficit here. All right. So very straightforward. If this is significant, long run causality. If this is significant, short run causality. All right. So this is how the steps to do on the ECM or the VECM considered model. Even the ECM steps are the same. It's just that we are more concerned on one single equation. Certainly, you need to test stationarity first. The I1 or I0, right? Which this is previously in chapter number 4. And then after that, if you use VAR, you can search for the maximum lag, right? Microfrit can do that. EView will do that automatically for you, so no worries on that. So for example, VAR2. VAR2 means that VAR of lag number 2, which I already shown you in chapter number 6. And then after that, test for number 2, the co-integrating vector. This V is not curriculum vitae, is co-integrating vector using Johansen-Jussilis in the environment of var, right? And then we will proceed depending on the results. If you still remember the co-integration result, depending on go back to chapter number 6, the slides. There's a 3 scenario of the result, or actually 4 types of result. Either you can get 0 if there's a 3 variable, right? 3 variable, in our case here, 3 variables. You can get not co-integration, r equal to 0. You can get r equal to 1. You can get r equal to 2, and then you can get r equal to 3. 4 different case, right? 4 different result with 3 different case. Why 3 different case only? Because 0 is considered one case, 1 and 2 is considered one case, and 3 is considered one case. Full rank r equal to 3. So this is the different 3 different cases of Johansen-Jussilis test. Angle and grandeur will not be able to do that, because angle and grandeur will only suggest co-integration and non-co-integration, but we do not know whether there's a 1 equilibrium, 2 equilibrium, 3 equilibrium, or more than that. 0 certainly we will know, because there's no co-integration, and there is yes co-integration or co-integration supported. But if even co-integration supported, let's say you have 3 variables, you do not know whether the 3 variable only exists 1 long run, or 2 long run, or 3 long run, right? So that's the limitation of angle and grandeur. Same thing goes to ARTL actually, right? So because they're built upon the same idea behind the innovation also, right? If there is one CV, then we estimate ECM, or sometimes we call it error correction modeling, or EECM. This one you can refer back to Rao article 2007. I'll share with you in eViews. In Ellipse, sorry, not eViews. This they call it general to specific modeling, or short run equation. Or more example, you can refer to the article of mine and my ex-supervisor, and Dr. Jerome article also. It's a very good article to refer to. All of these are available in the references, and certainly I uploaded also in the Ellipse for you to get to know this. Right? So for now, we shall stop here because the second part of it will be continue on the estimation. But then again, before we go off, before I go off here, I'll show you some of the important article actually, that very much related to what they are doing here. Here, this is the article Lau et al. Yeah, this is my article with Prof. Sazali and Dr. Phua Chin Hong, Dr. Phua, and yeah, certainly maybe most of you know that Prof. Sazali Abu Manso is officially retired from University of Malaysia Sarawak and the Faculty of Economics and Business, but but still contributing in the academia world, right? If you follow this procedure, you look at the methodology part, we apply the ADF and DFGLS, and then we move forward to co-integration test, the Johansen, and then the grandeur causality VECM. This is where I copy paste the slide just now from here, right? And then this will be in the chapter number 8 actually, the generalized variance decomposition, right? So this is one article which you can refer to, and the second important article actually by these two persons, Abul Mansur Masih and Rumi Masih. Very important person that I learned a lot of this. I learned where the VECM, Johansen, all these things come from, right? So this is the normal grandeur causality. Follow this article, and this is actually the VECM that they adopted in terms of the theoretical understanding, including the ECT. Same thing as what I presented, but this is presented in the matrix format, right? You can read through the article, and this part actually is where which actually I copy the slide from. All right, so this is another article which I can surely share with you, and surely another there are other articles too, right? There's a lot of article of them actually talking about this thing, and And the other important article which certainly we will discuss for this chapter will be this one. Right? Oh, it can't be opened here. It's okay, no problem. Also, is available in ellipse actually on the Granger causality, actually Granger non-causality, Clark and Mirza 2006. For time being, this is what the chapter about. For chapter number 7, I will have my part 2 of the chapter. Thank you very much. Adios.